In number 64, we have a closed loop carrying a current of 200 milliamps. The loop consists of two radial straight wires and two concentric circular arcs of radius 2 meters and 4 meters. The angle is pi over 4 radians. Question A, what's the magnitude and direction in or out of the page of the net magnetic field at the center of curvature P? Well, if we look at these wires, there's a couple quick notes on this one. These two wires right here carrying current towards, in this case, towards P and this one away from P, are not going to produce any magnetic field along that line. But what we do have is these two loops. This outer loop here is going to produce a magnetic field at point P, which is concentric with this, if you use your right-hand rule. And it's going to be pointing out of the page at point P. And if you think about the inner loop, the current is carrying in the other direction. Sorry, as I try to color this in very quickly. The inner loop is carrying current this direction. And if you think about this one's going to produce a magnetic field at point P that is pointing into the page at this point. So to find the net magnetic field here, I just need to figure out the magnetic field contributed by each of these two pieces. And it's actually not too bad. We're just going to use Biot-Savart and plug in what we know. For the outer loop, we're going to plug in, the radius here is 4 meters. And even though it doesn't look like this, their diagram's not very good, this should be pi over 4 or 45 degrees. So to figure out the rest of the arc length, we're just going to take 2 pi minus that. Again, just a quick reminder, arc length is equal to theta in radians times the radius. And we're going to need the arc length to actually be able to solve this part. Plugging in our numbers, the current is 0.2 amps or 200 milliamps. ds is going to be the radius, this is r, times theta. And theta in this case is, again, 2 pi minus that. It's all the rest of that, which is going to be 7 pi over 4. And again, plugging in the radius here, which is 4, we can solve this fairly quickly. And you end up with this, 2.75 times 10 to the minus 8 teslas pointing out of the page at us. That's that little red circle we have up here. Likewise, we can do the same thing for my yellow shaded ring. The inner ring is going to be the same exact thing. Again, the current's 0.2. ds now, my radius is now 2, both here and down below. And some of you might be able to see, oh, it's just going to make this value twice as big as it was before, or 5.5 times 10 to the negative 8 teslas, but this time pointing into the screen. What's the net magnetic field? Well, as you can see, we just need to add these two together. And what do we end up with? Well, net magnetic field is just going to be 2.75 times 10 to the minus 8 teslas pointing into the screen. And that's our final answer. Again, you can think about this as pointing in the positive z direction or z. This is the negative z or negative z direction. And just adding them together, you can very quickly solve it. Good luck. I hope that made sense.